Okay.
Dr. Takahashi and colleagues prepare this paper entitled, Does Commitment to Savings Alter Seasonal Poverty Dynamics Among the Ultra Poor? Evidence from High Frequency Data. Dr. Takahashi, are you ready to make a speech and presentation for us?
Yeah, okay. Thank you very much for introduction. I'm Kazushi Takahashi from Gripus, Japan. The present paper is a joint work with 7 other authors here. And the motivation of our study is to answer simple yet unresolved question, that is, why are the rural poor don't take precautionary measures against seemingly unanticipated seasonality? So it is frequently mentioned in the literature that the rural livelihoods in developing countries are vulnerable to seasonal weather cycles. The primary reason is because most rural households depend on agriculture for their livelihood, which is affected by seasonal weather cycles. And income and expenditure are generally highest right after the harvest and lowest during the agricultural rain season due to few working opportunities in the agricultural sector. So this figure is drawn from Parkson in JP paper from Thailand published in 1993, and the rural monthly income is like this line, and the urban income line is this line. So it is clear that the rural income tend to be more fluctuated than urban areas from one season to another. Moreover, the price of commodity tend to be highest in the agricultural rain season because of low supply. So in the rain season, what happens is that income is lowest, but price is highest. And as a result, real expenditure is lowest, which causes hunger and malnutrition. So this is a common understanding of the seasonal dimension of poverty, but this seasonality is repeated every year. So it should be anticipated. So why the rural poor don't take precautionary measures? This is puzzling, especially when we consider that rural poor take precautionary savings in the form of livestock and stock grain for unanticipated shocks like extreme rainfall. So our study aimed to address this puzzle. We first show the degree of consumption volatility of our sample household, and then ask the effectiveness of a policy intervention to mitigate the seasonal dimension of poverty. In order to do so, we have conducted a unique high-frequency survey, generally twice per month for 10 months over 2 years, in order to trace the consumption pattern of the ultra poor households living in northern part of rural Bangladesh. So we don't say that this is actually so-called big data, but we have lots of data points. And the conventional approach to the ultra poor is to provide a package of intervention, including asset transfer with technical assistance, known as a graduation program initiated by BRAC. In this research, we focus on the role of commitment savings. A randomized control trial is conducted with two treatment arms, where the first treated group can receive the premium interest rate of 50%, and the second treatment group receives the market interest rate of 8% per year. This is commitment savings in that interest is paid if the treated household can save their money until the hungry season. And I'll explain the experimental design a bit more detail later. And our study site is located in Gaibandha district here. In the study area, rice is the most important crop for both income and consumption. And typically, rural living is closely connected with rice production cycle, ours from May to August, and Amman from August to December, and Boro from December to April. Amman and Boro are more important than us in terms of production. And due to the lack of sufficient employment opportunities and the stock of previous seasons, the rice production is running out, people suffer hungry season called Monga from September to November. According to Rahman et al., the Monga is a hunger and a famine-like situation that prevails in the northwestern region, particularly during the rain season, as the poorest do not have access to livelihoods and work. And moreover, our study sites are prone to floods. The study area is vulnerable to river erosion like these photos, and most of households cannot have access to even rice land. They generate income from daily agricultural wage laborers or small livestock rearing like goats. And in this study, we cover 180 households from 6 villages and 3 from river islands and 3 in river basin. For each household, we conducted a household survey 18 times per year from 2 years from 2018 to 2020. And there are some variation of the timing of surveys across households, but those household surveys are typically conducted twice per month. And in each year, we mainly cover from April to December. And if the number of surveys is less than 18, we do it in January. Unfortunately, we cannot cover February to March because of budget constraints. And in each survey, we mainly ask household consumption in the previous week. And this short-term recall survey has an advantage that has little recall errors. And from the consumption module, we construct per capita expenditure, which is divided into food and non-food expenditure, converted into the real term, and per capita calorie intake, and lastly, household dietary diversity score, which measures out of 12 food categories, how many categories a household has consumed in the previous week. As briefly explained previously, we implemented a randomized control trial RCT to examine the impact of access to savings on the consumption in the second year. Our savings scheme started from June and ended at the mid-September 2019. And if a household can save until the mid-September, that is the beginning of monga season, a household can receive the pre-specified interest. The upper limit of the saving is about $48 US, which is about a half of monthly expenditure of the sample household. We provided 2 different treatment terms with a premium interest rate of 50% or a market interest rate of 8% per year. We differentiate this interest rate to examine whether access to savings scheme alone is sufficient or whether additional incentives are required to save for monga season. The randomization is implemented at the household level within each village, and a control group has no opportunity to save in our experimental saving account. Let's move on to the result of the first year consumption. Everything except for dietary diversity is a per capita basis. And what we found here is that all outcome variable, actually, I excluded real non-food expenditure from this figure because of the space limit, but all of them are well balanced and show the parallel trend before our savings experiment. Actually, calorie intakes look somewhat different, but none of them are statistically different from one category to another. And what is also striking is that the consumption of the household is almost always below the poverty line of $1.9 US, or national nutrition-based poverty line represented by this dotted line. And it is also noteworthy that the consumption level varies significantly across seasons. Consumption by any indices sharply declined from September to November in the monga periods and gradually recover from December. Since the number of observations in January is somewhat small, it is imprecisely estimated with large standard deviation. And this table shows the total savings amount and also savings in each month for each treatment. The uptake rate is about 86% for the premium interest rate group and 78% for the market interest group. And this suggests that our experiment attracts the majority of the treated households. But the mean savings amount is far below the ceiling of upper limit, which is 4,000 Bangladesh taka, possibly because of severe capacity constraint. Most of them save until the mid-September and receive the pre-specified interest. An important question is whether our experimental savings alter seasonal poverty dynamics. So we estimate an intention to treat effect with the following equation, where the CI-JTM is the outcome of household I in village J in the survey period T at month M. We have 5 sets of outcomes, that is monthly household expenditure, food expenditure, and non-food expenditure, calorie intake, and HDDS. The first 4 are per capita basis, and the first 3 are converted into the real term and taking logs. And independent variables include month dummies interacted with each treatment status. The coefficient of alpha 20 captures the average consumption of the control group at each month, controlling the covariates. And alpha 21 and 22 are the coefficient of interest, which measure the differential average consumption of each treatment group relative to control group at each month. In addition, in the split of the local informal risk sharing model à la Townsend, we control the real per capita income at the survey period T in month T, which hopefully captures all idiosyncratic shocks. And also, we control the village month specific dummies, which may capture the covariate shocks at each village in each month. And finally, we introduce a household fixed effect to capture all time invariant and observable household characteristics. So let's first look at the impact of our intervention on household with the premium interest rate. The first 5 columns indicate the result without the control of per capita income, while the last 5 columns indicate the result with it. The result indicates that the consumption of this treatment group for total per capita expenditure, food expenditure, and calorie intakes significantly increases in October relative to control group, that is the middle of the acute hungry season of Monga. Once we control the per capita income, non-food expenditure also becomes statistically significant. The point estimates show that the per capita household and food expenditure increases by approximately 10 to 12% with and without controls. However, these impacts do not persist, perhaps because households consume most of extra interest immediately after they receive it in the end of September. It is also interesting to see that they do not sacrifice consumption level during the savings phase from June to September. On the other hand, household savings at the market interest rate group do not benefit from our intervention. So moreover, somewhat unexpectedly, they appear to decrease their food consumption and diversity after October, even though the coefficients are only marginally significant in December. So these are the main results, and we conducted a bunch of additional analysis. First, because the income can be potentially endogenous, we replace the income by another idiosyncratic shocks for illness or death of family member in the past 1 week. And also we include an additional control variable per capita expenditure in the same month in the previous year, which can control households' preference of monthly expenditure pattern. And our results are robust to these specification changes. And then we check if there is any spillover effect, and we check informal transaction within and outside of the village members and do not detect any signal of spillover effect. We then examine whether our intervention crowd out the existing informal risk sharing arrangement, but do not find such behavioral change. And finally, we conducted a multiple hypothesis testing to check if we might obtain the false positive just by chance. And the result reveals that at least we see some positive impact of the premium interest rate group in October. Okay, so this is the end of our presentation. So let me wrap up. We basically find that our intervention temporarily increased the consumption level of the premium interest rate group in the acute Monga season in October, but we do not find persistent impact. So from the policy perspective, giving savings account only might not be effective. So maybe we may provide some we may need to provide some complementary intervention like increasing employment opportunities and also skills of the per household. Thank you very much.
Thank you, Dr. Takahashi. Okay, do we have 5 minutes for our question and answer? If anyone have a question or comment, please.
Yeah, I have a question.
Yeah, okay.
So it's very interesting to find that the treatment of getting the market interest rate have no significant impact or even negative impact. I'm wondering whether there are possible spillover within village. So those households get this market interest rate intervention, they lend money to those get a treatment with higher market interest rate to get bonus from the first treatment group. My second question is about, is there any possible income effect from this treatment group, particularly for the first treatment group, since they get a very high interest rate premium from this saving, and they expect they will get higher income from saving.
Okay, thank you very much. For the first question, we looked at the detail of the borrowing within the villages and also outside the villages, and we do not find any signal of the spillover effect, even between the treatment one and the premium interest rate group and market interest rate group, or premium interest rate group and control group. So we don't see that spillover effect is very serious in our study. And also there might be some actually the income effect, because in the premium interest rate group, they received extra interest, but it doesn't lead to some persistent income. It doesn't have persistent income effect. It is only the temporary. So we don't see any significant increase in investment.
Thank you.
Okay.
So this is yes. Can I wrote my comments in the chat box,
yes.
but simply it's still difficult for me to understand what's going on. T1 group supposed to cut expenditure when taking up saving, and then later on, longer season they increase consumption. So I can understand this possible consumption smoothing mechanism, but it's not necessarily found in that empirical analysis. So I'm trying to understand in terms of the household budget constraint and accounting, what's happening here.
I think so. The first possibility is that in the premium interest rate group, actually they received extra interest rate, so which has some additional income effect, which allow us to increase their consumption level. They do not sacrifice saving consumption from June to September. And in the October, we look at the detailed item by item consumption pattern, and there is some relocation from temptation good to staple food and also ceremony events in the premium interest rate group. This is what we found, but we are not quite sure what is the exact mechanism underlying this temporary changes. So we are now conducting a follow-up survey, and we want to find some detailed mechanism.
Thank you very much.